So I wanted to do another implicit differentiation example, just not talking about it in general, but just looking at a specific example. So we have a function, or rather a relation, 2x squared y plus 3xy squared equals 1. And we are told that we care about the point 1, comma 1. Which is rather interesting because that's not even on this curve, because if we plug in 1 and 1 we get 5. So this must be one of those fun questions where there is an error in the textbook. So I'm going to change it. If I look at instead the point 1 comma negative 1, now it should work because making the y value negative turns that into a negative 2 and a positive 3. Okay, so we're going to do this and we're going to find the normal. We want to find the normal line at 1, negative 1. So first we take our derivative, and we take our derivative of everything. If we touch the letter y, we're thinking of it as a function of x. So on the first term, I have a product, so I do product rule. F prime g, so 4x times y plus f times g prime, dy over dx. Then I have another product rule, f prime times g, so 3 times y squared, plus f times g prime, 2y times dy dx. The reason it's not just 2y is because y is not your independent variable. Y is actually a function of x. It's implied. That's why we call it implicit differentiation. The derivative of 1 is 0. Don't forget about that. A lot of students forget about that. The number 1 is a constant. Constants have 0 slope. If I collect my dy dx terms, I can see that dy dx was multiplied by 2x here, 2x squared, and multiplied by 3x times 2y, aka 6xy there. I'm going to move every other term to the other side of the equation, so I'm going to subtract 3y squared, and I'm going to subtract 4xy. I'm going to divide, so I have negative 3y squared minus 4xy divided by 2x squared plus 6xy. Remember what the derivative tells you. The derivative tells you what's the slope of the tangent line at a given point. The point that I'm given, well, first they gave me the wrong point, but then I changed it. The point that we have is 1, negative 1. So that tells me that the slope of the tangent line, I get negative 3, plug in negative 1 for y, squared, minus 4x, y, 2x squared, plus 6x, y. I wish my pen wasn't skipping around. Okay, so this is 6, 1, negative 1. So the slope I get for my tangent line is negative 3 plus 4 over 2 minus 6, 1 over negative 4. This means that my normal line, which is perpendicular, has a slope of positive 4, because they have to be opposite reciprocals. Now, to create a tangent line, I'm going to go over here. You can use point slope form. Y minus the y value of the point, which is 1, equals m, which is 4, times x minus the x value. If you want to make that into slope-intercept form, distribute the 4, so 4x minus 4, and then bring the 1 over from the left side, so you get 4x minus 5, and that line is normal to the curve at the point 1, comma negative 1.